The topic today, as you can see, hands-on learning for non-technical people, which is probably strange at the technical conference. So a little bit about myself. I call myself an amateur. But if you look at that from French, it says one who loves or a lover. So I love what I do, so I'm an amateur. And my formal education was ages ago, I don't remember, 1990 or something like that, as a machine mechanic. And now see where I ended up. So all the rest between then and now, I learned by doing. So I can say I'm proud to be an amateur. Let's talk about reality real quick. And the question is, how do you choose to see the world? Your world. Do you choose it to see it as something that happens to you? Or something you create? And quantum science tells us that your consciousness forms your reality. So actually your life happens from the inside to the outside. So, few questions. How many of you are very technical by show of hands? A few. So all the rest is non-technical, I assume. How many of you are designers? Okay, a few designers. How many of you are managers? Okay. And how many of you just realized that you're in the wrong room? Okay. No one. So we can continue. Let's talk about perspective. So you have a role in your work, as you said, you're a designer, you're a technician or a manager. Also in private life you have a role, and it comes with certain perspectives. So to learn something, which you probably came for, it's good to get a new perspective. So everyone get up your seats, please. And then sit down somewhere else, not where you were. That's an idea too. And then once you sit down, say hello to your new neighbor, left or right, or both. So that was just a little perspective change. You now have a new perspective just by sitting somewhere else, and maybe you have a new friend too. You never know. So let me tell you a story. Imagine you're a little kid again, and you wake up in the middle of the night. Even you are lying in your warm bed, the air feels very cold. It's dark and quiet, and you can only hear the clock ticking. Do you know this situation? That you suddenly have the feeling that someone is standing behind you and a cold shiver is running down your spine. You turn around and there is no one there. How many of you know that? So you feel the cold air in the room and you begin to shiver. Suddenly you have the feeling that something big and threatening is lurking behind the curtain. Golden eyes sparkle from the corner where your toys usually are. Everything suddenly looks big and threatening. You are afraid. You are now looking for help. Who can help me? Of course, your favorite people can help you. Your parents. Probably many of you would look for them for help in this situation. So you run from your room into the parents' bedroom. There's only a bit of light in the hallway from the moon shining through the windows. Your naked feet scurry across the cold stone floor. But oh no, the beds in the bedroom are empty. So you stand there on the cold floor and you have 1,000 thoughts going through your head. Where have they gone? Are they coming back? When will they come back? What if they just left? But how does this relate to technology? Fear of the unknown. Especially probably with topics that seem hard to understand. For example, advanced AI or robotics. Fear, or more specific, fear of the unknown, makes us get stuck. So what can you do with that fear? You can start to understand the unknown. Then that fear and block can dissipate. My name is Markus, and I run technical workshops for technical and non-technical people since 2015. My goal is to get topics like AI, robotics, programming to kids, but also teachers, designers, managers, and everyday people. So I imagine a world where kids learn about AI already in school. So let's talk a bit about humans. Humans create. From the beginning we were on the world, we had our hands and then tools to create something. Everything that you see here was created from out of humans. So we have a creative mindset. We look at something and we see the possibilities. And these days we use technology as an enabler. So there is a process that we created that helps non-technical people with the understanding of complex technology. And there are 5 keys to this process. Let's go through them. First one, H. Stands for heart, the understanding and the feeling. When we use our heart, when we feel something, we can retain what we learn better, compared to when you only understand something with your analytical mind. A. Actual or applied, not only theory. So if you do applied learning, you again retain better what you learned. If you only analyze or think about something, you will not have the full experience. If you only see a formula and not the applied solution for that formula, again, you will not learn as effective. N. Nature, from the bottom up, from small to big. In nature, small building blocks are the base of something complex. For example, we as humans are amazingly complex, but we are made out of very basic parts if you break it down. So if you looked at the human from the first time as a system and would try to understand it from the top down, you'd be like, this is too complicated. I have no idea how this works. But if you start to look at it from the other side, from the basics up, you can start to put one and one together. Once you understand the basics, the basic building blocks, you can then go higher and get a more complete understanding. Then D, divide into steps. Again, complexity gets easier if you divide it into steps. For example, if you stand in front of Mount Everest and you want to go up top, Same thing. Well, how do I get up there? You break it down in steps. What do I have to do? What do I have to do first? And what do you have to do then? You just can't, usually you can't just jump up to the mountain. So even with a mountain as big as Mount Everest, you start with a small step, and then step by step you go up. And we have, yes, for serious gaming or play. So instead of discussing theory and complex formulas, you can instead use playful interactions with serious games and play. So you actually gain an intuitive understanding instead of just focus on the mathematical or technical concepts that you analyze with your head. So, if you put everything together, all those, you get hands. And again, we are back to humans. We create everything with our hands. By using our hands and by using hands-on learning, we can more easily get a grasp on complex concepts by experiencing them instead of just looking at them or thinking about them. Use your hands. So let's apply these keys to a topic. Let's take one that's harder to understand. AI, robotics. How many of you have a solid understanding of AI or robotics by the show of hands? I have a bit. Okay, so I've come to the right place. How many of you would like to get a basic understanding using those keys I just talked about? Yes. Yeah, very good. So the first step is a solid understanding of some concepts, and in our case, reinforced learning. So the goal is we want to have a robot, an AI-powered robot, that will follow a light source. But we don't want to program it. We want it to learn itself how to follow the light. Does that feel like a daunting task for you to go through? I'll show you how you can move through that and get an understanding of how AI and robotics work. So let's do a little demo. If I figure it out. Oh. Ha, there we go. So here's a little program that helps understand some of the concepts. For example, if you want in AI, if you want to have someone to understand the vastness of search space, so how many solutions do you actually need to find for a robot to follow the light? You could talk about search space as a concept, but you don't get that far. So let's see. Let me see how I can show you. So search space. Every one of you probably understands one dimension. You use that a lot. Also 2 dimensions. But now we already start to understand how big the search space became just by going from 1 to 2. But it's by understanding, it's by intuition that you see it visually. So 2D is also something we regularly do. And 3D, too. But now see what happens. Now you can understand a search space gets way bigger just by looking at that picture, going from 1D to 2D. 3D we use a lot. 4D, not that much. See what happens. See how big the search space now gets. And in AI, you have huge search spaces because you have so many parameters. So let's go to 5D. Or 6. 7. So now you have just by this example, you have an intuitive understanding how big a search space is if you start to look for a solution for an AI problem. I didn't show you any formula or any explanation. Just by looking at it, you can already see it's just huge. So let's see. Back to menu. Well, for example, in AI, we use a lot of genetic algorithms. An algorithm that starts somewhere, and then a solution is applied, and then a part of the results is selected, and then going into the next generation. That's the theory explanation. So now let's see how we can use that to understand better genetic algorithm. So here we have the first generation of our, I don't know what they are, little fluffy toys. Let's say we want, in the next generation, we want to have more yellow ones. I would say take this one and this one and this one. We also want them to be like that. No, this one. This one. This one. Looks good. Okay, now it took our selection and generated new ones on the basis of what I selected. So that's a genetic algorithm. It looks at, it selects, you can choose, usually it's like 50%, what looks right, what works, and then goes into the next generation and you use that as a base. And then again, we select. Now we say, oh, okay, now it's getting lighter. And it's also turning sideways. Let's take these. So those all look okay. Yeah, this one, no, this is the wrong way around. This one maybe, yeah. Yeah, this one too. Okay, now is the next generation. But now you see, in every generation, we're getting closer because we're only selecting the ones that are fitting. Survival of the fittest, maybe. Selection. It actually goes back to nature, where you see the same concept. Okay. Back to the menu. But now we actually want to go more into our goal. We want to have our robot being able to see the light or find the light. So we go into that simulation. Here's a virtual environment. See what happens. So now we have 10 robots, a light source, and every one of them looks for light, but it doesn't know how, it just drives around. And then it collects how much light does it collect by going this way or this direction, just any direction. And at the bottom, you see generation 1. So that's the first generation, and they're probably just driving around. And then at the end, we look at all of them. How much light do they collect? That's happening now. Each of that strategy. How many light do they collect? And then we go to a genetic algorithm we talked about before and take the ones that selected the most light. All the ones that didn't collect a lot of light, we leave them out and take the fittest virtual robots we take and put them into the next generation. And since we're doing that in a virtual environment, of course, it's faster than trying that out with physical robots. Because you can have that run for hours, days. Now we're in generation 2. And then they will get a bit better because those new robots are all based on the previous generation who was better than the first generation. Now we're already deep into AI and reinforced learning. But I didn't show you any concept or formula. But still you saw how it works. So we leave that running for a few hours. And then we actually have virtual robots that can drive towards the light quite good. Just in the virtual environment. So let's see. Stop. And then of course you can change the experiment, have more robots at once depending on the speed of your PC or Mac. So you can play around with those and actually watch what's happening. You see the first generation just going somewhere. And then maybe the 10th generation is already quite good in going into the light. So again, you can apply, try out, play, and then see the result. Now, the really interesting part. Let me go back here. Where's my mouse? So in a little time, we went through search space, genetic algorithms, and even reinforced learning training of a virtual robot. And it's only 1346. What now? So now we build a physical robot from scratch. Here you can see all the parts. Every one of you should be able to put one of these together. It's not that hard. You want this robot to represent the one we have had in our simulation with 2 motors and 4 light sensors. So basically replicate the virtual world into the physical world. And since the robot kit is quite basic, you can build that probably in half an hour, every one of you, with some explanation. So first assemble the wooden parts, put in the motors, and then start to understand how does the power go from the battery into the components. How do the electronic components talk to each other? How do the light sensors work? And then you can even make it look nice, or maybe even a bit alive by decorating it a bit with eyes. So which keys do we use in that step? The heart, you build your robot, your little toy with your own hands, and you can even give it some personality that gives you a deeper connection to it. And applied, it's no theory because you're actually building it with your own hands again. And again, nature, you start from the basis, mechanics, and then electronics, and how does it get power? And then how do they communicate between each other, and how do the sensors work and feed their data? You get an understanding by building it. And serious play as well. You make it life-alike, for example. You add antlers or eyes, and then suddenly it looks like a little animal that you built. So now the first step is putting it all together. So we had understanding of the concepts, then we trained a virtual robot, and then we built a physical robot, and now we can put everything together. So we transfer the trained network, the trained neural network. We transfer it from the virtual robot to the physical one, and try it out by taking a flashlight and pointing at it, and then observe and change if needed, and try again. So an iterative process. So here we have so you saw it in the virtual simulator, and now you see it in real life with something you built yourself. And it works quite well. You didn't program it, it learned by using AI. That's quite fascinating. Some people even had some starting to form a little bit attachment to their little toy or to their little life form. It was very interesting. So again, the keys used is the heart, observe and change. See the changes in behavior. If you train it again and transfer it again. Applied, you have a direct connection. You see the neural network and the behavior. And then you can, after you try the first one, you can go back and train it again and try to influence it and see, okay, what could it do different? Train it, transfer it again, watch it, observe it, go back. So you're actually doing AI training. Serious play, again, you're playing. You can play with the robot and you can see where the limits are. What does it do good? What does it do bad? Okay. So, in a very short time, you have now learned a lot about AI and robotics by doing, experimenting, and playing. I didn't talk that much about theory or concepts or formulas. I gave you all the tools so that you could try it out yourself and experience it. So what happened from when we started and where we are now? You came with your current perspective, with your current seat, you changed that. You might have had fears from the unknown. You gained a new perspective, not only by sitting somewhere else, but also you dove right into the topic of robotics and AI. So if you look at the world today, to wrap it all up a bit, I think many of us have lost the connection to our nature, to our hands. And it would be good to regain our power using our hands by hands-on learning. Now, if you go even back farther, remember my story when I was a little child? My parents, of course, came back. They didn't just leave me alone, of course. Shortly after I was looking for them and standing there, I heard them coming home and quite happily went back to bed. So in general, a life governed by fear is a life from the outside, a reactive life where you react. A life governed by love and understanding is a life lived from the inside, an active life and a creative life. Which one do you think leads to a better world for us all? For myself, I choose a life governed by love, understanding, and creativity. Now the question is, which one do you choose? So here are some websites to learn more about the robotics and also hop on tech. How do we get people a better understanding of technology. I also really would like to hear from you. How would you solve that problem, that people can get a better understanding of future technology, even non-technical people, or even write to me how you could help with that. I don't want to do it alone. So talk to me, write to me, tweet to me, Facebook, Instagram, I don't know. A little advertisement. On Sunday, there is a masterclass where we spend one day going through the whole process I just put together in like 20 minutes. And at the end, you can take home your AI-powered animal toy. I think there are still spaces available. It's on Sunday from 9 to 5. That was it. Thank you, Build Stuff, for inviting me first. Then for all of you for listening to me. And as a thank you, I have some, as I'm from Switzerland, I have a giveaway. So the first person that comes up to me can have it. So thank you. That was it. Let me check for questions. I think people use Slide.io these days, but you can, of course, also ask me questions directly since I'm standing here and we have enough time for questions. Yes. I'm sorry? Maybe afterwards? Yeah, I could probably bring it like later in the day and show it around. And of course, then on Sunday, you can build and program it. Selected, yeah. Yeah. Oh, that's actually a good question. Once we go into the physical world, this robot doesn't learn anymore. It just behaves. So it's actually a very not like unlike humans or even animals that continue to learn. This concept, the learning only happens in the virtual space. Because it takes time, like it takes 2 hours, it takes like usually 2 hours to train it from just driving around like crazy to actually going into the light. And then you take that result, like a fixed brain, and install the fixed brain that can't learn anymore and install that into the robot. Next step AI would be, of course, then how would one learn? But that would be another topic and would probably need a bit more processing power than this one, which is like 8-bit, 12 megahertz, something like that. But yeah, maybe that's the next generation where you can learn. And you can also apply it to like a child. They also learn by trying, but the only thing is you can't have 100 children in a room and then train them faster, and then also you cannot transfer it to one child and then it will be better. So it's not the same. But it's actually, there's one actually very interesting aspect to it with kids. You might know drugs and what happens. So we can actually give those virtual robot drugs so that it overreacts to the input from the light. And then it just drives around crazy. It doesn't matter how long you train it because it overreacts. And this you can apply to kids or even adults. If the same happens, they can't learn anymore. And then in their life, usually the same happens. They just run around like crazy if they take drugs. So it's actually interesting to always apply it from virtual to physical, even into our human world. Any other questions? This is like 40 euros, more or less. Those are made on a laser cutter. So I do that myself. Some parts are 3D printed. And the standard parts are from China. So you can maybe even get it farther down. So it's very standard components, and the rest which are custom made, you can go to a fab lab, or if you have a 3D printer in a school or something like that, you can also do it there, like 40 euros. So quite inexpensive, depending on the country, of the country you're in. The goal is to really start with 10. Maybe not with AI, but with the same concept. Let them explore and play and get into programming. For example, with visual programming, I started with kids that are 10 or 12, and that's no problem. But I think the goal should be to make it even easier and start at that age. Seems crazy at the moment, but I think it's possible. Just imagine what happens if children get an understanding of AI with 10 or 12.